Okay, example 7 has a grain silo consisting of a cylindrical main section with a height of 45 feet and a hemispherical roof. Hemispherical means half a sphere. In order to achieve a total volume of 25,000 cubic feet, including the part inside the roof section, what would the radius of the silo have to be? So the height is 45 feet, that's set in stone. That's not going to change. We want the volume of this thing to be 25,000 cubic feet. The only dimension I don't know is the radius. The radius of the hemisphere is the same as the radius of the cylinder. All right. So what I'm looking for total volume of this grain silo is the volume of the cylinder added to the volume of the hemisphere together makes the total volume of 25,000 cubic feet. All right. So if we take a look, I'm going to do the cylinder in blue. So we're going to do the volume of the cylinder in blue. The volume formula for a cylinder is the area of the base, which is, in this case, pi times the radius squared. The base being a circle, right? And the radius is unknown at this point, so pi r squared is the best I can do with that. Times the height, which is 45 feet. That is the volume of the cylinder. The hemisphere, I'm going to do that volume in red. Volume of a sphere is 4/3 pi r cubed, right? We have half a sphere. So the half a sphere is going to be 1/2 of this volume of a sphere. So 1/2 of 4/3 pi r cubed. Better known as 2/3 pi r cubed. So just like that, we can very easily create a volume formula for this structure. And we know the volume is supposed to be 25,000 cubic feet. So what I'm going to end up doing out of all this stuff is I'm going to get 45 pi r squared, this part, plus 2/3 pi r cubed, which is that part, equals 25,000 cubic feet. And just like that, I've created myself a polynomial structured equation. And I want to use Newton's method to solve it. Couple things. First thing I notice, there's a fraction. Okay, I can multiply everything by 3 to get rid of that fraction. That's your choice. You don't have to do that. You can do it. Take your pick. I like to get rid of the fractions. Anytime I don't have to hit a divided by key on my calculator, it makes me feel better about myself. 3 times a non-fraction just triples it, so it's 200, or not 225. Try multiplying properly. 135 pi r squared. 3 times 2/3, the 3's cancel, so I'm going to get 2 pi r cubed. And I'm going to multiply 3 times 25,000, that's 75,000, but I'm going to move the 75,000 over to the left-hand side. So minus 75,000 equals 0. Remember, with Newton's method, it's up to us to make the function equal 0. That's what f of x is going to represent. All right, so everything equals 0. I'm trying to find out the value of r that makes this true. This is going to be y sub 1, our f of x. And y sub 2 for our calculator is going to be the derivative of y sub 1. So 2 times 135 pi r is going to be 270 pi r. And 3 times 2 pi r is going to be, let's see, 6 pi r squared. And then minus 75,000 represented 0, right? Alright, so I know what y1 is, I know what y2 is. There is only one solution to this problem, right? One radius is going to make it true. Okay, we can verify at the end that we can put whatever r value we get in there and make sure we get the correct volume out of it, in case there's more than one solution to this. Only positive solutions matter, right? Because we're looking for a radius, it should be positive. So I'm going to type in y1 is 135 pi x squared plus 2 pi x cubed minus 75,000. Before I type in y2, I'm just going to do a zoom 6 real quick. Actually, I'm not even going to do zoom 6. I'm going to window. I'm going to start at 0, go to 10. Because again, only numbers happen that are positive matter, right? Maybe the answer is between 0 and 10. I don't know. Hit graph, see what happens. Look at our little yellow wheel up there to see if it's working. When it's done working, we know the graph's been done. Didn't show up, which means that our answer is bigger than 10. So I'm going to change the window 0 to 20 and see what happens. It's working again. Hopefully we'll see some graph this time somewhere around here. Oh, there it is. Found it. All right. So the answer is right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Between 12 and 13. So a good guess for radius will be 12 maybe. All right. So if I go back to y equals now, I'm going to enter my derivative as y2. So 270 pi r, which we're using x instead of r, plus 6 pi r squared. Again, we do x squared. And then I'm going to quit there. I'm going back to Newton's method, which again is still on my calculator, ready to go. My guess is 12. And they want the radius. Doesn't specify. Let's go 4 decimal places. 12.2353. If that's correct, right? If I were to put 12.2353 right here, it should equal 25,000, right? So if we try it out, just to be safe, 45 pi times 12.2353 squared plus 2 pi times 12.2353 cubed divided by 3. 24,999.91263. That sounds good to me. So that must be the right answer. So there you go, 12.2353 feet. If it doesn't specify decimal places, give me more rather than less. I mean, typically we go a couple decimal places. More often than not, they're asked for 6, 7, 8 decimal places. So, you know, something like that. Maybe 4 is probably good. If you gave me 12.24, I wouldn't count it wrong. If they don't specify, don't give me 10. Don't round to the nearest 10 or anything weird like that. But, you know, give me a couple decimal places at least on these problems.